Hello students, welcome once again to the MSBT online e-learning program, MSBT Lead Learning at Your Doorstep. I am Mrs. Rita Vora, lecturer in Electronics and Telecommunication Department of Thakur Polytechnic, Kandivali, Mumbai. In the last two sessions, we have studied in the course of microcontroller and its applications all about what is a microprocessor, a microcontroller and a microcomputer. After that, we studied about the three types of buses, the address bus, the data bus and the control bus. Today in the unit 1, basis of microprocessor and 8051 microcontroller, we will be discussing about the two types of computer architectures. The contents that will be covered in this session are the introduction about the types of architectures, the two architectures, one of which is the Harvard architecture, the Von-Neumann architecture, and we shall see the difference between the Harvard and the Von-Neumann architecture. Learning objective. The learning objective of this session is explain what is Harvard and what is Von-Neumann architecture. After the session is over, you shall be able to answer questions like draw the neat block diagram for a Harvard and the Von-Neumann architecture. What is the concept map showing us the two types of computer architecture? One is the Harvard architecture and the other is the Von-Neumann architecture. Let's start with the introduction. Basically, microprocessors or microcomputers or microcontrollers, they are classified into two types of computer architectures, the Von-Neumann architecture and the Harvard architecture. These architectures, they represent the different ways of exchanging data between the central processing unit and the memory. The general purpose microprocessors, they follow the Von-Neumann architecture, while the microcontrollers, they follow the Harvard architecture. Microcontrollers with Harvard architecture are also referred to as RISC microcontrollers. RISC stands for Reduced Instruction Set Computers. It is also called as hardwired architectures. RISC processors use a small and limited number of instructions and they use simple addressing modes. Harvard architecture was basically developed to overcome the bottleneck of Von-Neumann architecture. As you can see in the diagram, Harvard architecture makes use of two separate memories for data and code, or you can say program. Microcontrollers with Von-Neumann architecture are also called as CIS microcontrollers. CIS stands for Complex Instruction Set Computers. CIS chips have a large amount of different and complex instructions and they support many addressing modes. Von-Neumann architecture was designed by the famous mathematician and physicist John von Neumann in the year 1945. As can be seen in the diagram, there is one common memory for instructions and data in the Von Neumann architecture. Let us now discuss the Harvard architecture in detail. As can be seen in this diagram, we have separate memories for data as well as code with their independent address and data buses. So it supports parallel buses for data and memory. So as seen here in the diagram, there are 8 bits which can be transferred between the RAM or the data memory and the CPU, and there can be 12, 14 or 16 bits which can be transferred between the CPU and the ROM, which is the program memory. Because of this, the size of the address and data bus we can say may be different. Also, the data and code are fetched simultaneously and hence this increases the speed of the system. The few examples of the Harvard architecture are shown here as the PIC microcontroller PIC 16F84MC, SHARC, which stands for Super Harvard Architecture Single Chip Computer DSP, and the ARM9 microcontroller. Students, it's now time for quiz. So attempt MCQ set 1. Coming to the Von-Neumann architecture. In the Von-Neumann architecture, the programs and data are stored on same memory space. So here in the diagram, you can see that there is one common memory for program and code, which is ROM and RAM memory. It uses the same bus for fetching code or program as well as data. The design of the hardware is simple since there is only one memory, but since multiple fetches are required for data and code, the speed gets affected and they are comparatively slow. While processing the address and data buses are first used to fetch the program byte and then the data bytes will be fetched, and this process becomes time consuming. This sharing of this common bus, due to which an instruction fetch and data operation cannot occur simultaneously or at the same time, and this is referred to as the Von-Neumann bottleneck. You can see here some of the examples of the microcontroller processors which follow the Von-Neumann architecture are the Motorola 68HC11 microcontroller, the ARM7 Pentium processors, and MSP430. Let's now compare the Harvard and the Von-Neumann architecture. As you can see here, there are physical separate memories for the instruction and data which can be seen in the diagram here. Whereas in case of Von-Neumann architecture, there is a single memory for both program and data. So Harvard architecture uses physical separate memories for instruction and data, and Von-Neumann is using single memory for instructions and data. Because of this, there is physical separation of program and data memory, as there are two separate ICs used for ROM and RAM. But in case of Von-Neumann architecture, there is a common memory for program and data, and hence some space is allotted for the program or the code and some space is allotted for the data in case of the same memory used. And hence we say that the distinction between the program and data is logical. In case of Harvard architecture, separate data and dedicated buses for both instructions and data. Here there is, as you can see, single bus is required for instructions and data. The instruction and data here can be fetched simultaneously, as there are separate buses for instructions and data, which helps post execution, which also increases the speed and the performance. Here the instruction and data have to be fetched in sequential order, and hence the speed is reduced and this affects the performance. The design is complicated since there are separate memories and separate buses for program as well as data. Here the hardware design is simpler compared to the Harvard architecture. Now you should be able to attempt the MCQ set 2. So let's summarize what we have studied today. We have two types of computer architectures, the Harvard architecture and the Von-Neumann architecture. Harvard architecture uses separate memories for data and program. So the speed of Harvard architecture is much more compared to the Von-Neumann architecture. The Von-Neumann architecture is using a single memory for data and program, so its speed is slow. Thank you.